let's do them. So we had a Golang meetup last week, and we had some questions that we can't answer, unfortunately. So I sent those questions to you, and maybe you could answer on them or add some kind of comments or your experience, something like this. So
Yeah.
we start then, if you have a few minutes to answer.
I'm trying to figure out the best way to do this. I can mostly answer the questions by talking, but along the way there's a few links and or code snippets I want to share. What do you think the best way to do that is?
I think that would be fine if you just share your experience, some links maybe. Looks like something wrong with your microphone. It's pretty noisy.
Yeah, I'm getting a little static when I hear you. Are you hearing something similar?
No, I'm not doing anything. I'm just hearing some kind of. Okay, I think that's my echo, maybe.
You think what?
Maybe it's my voice, just echo.
I don't know. Sometimes I have this problem when I do Hangouts. The first time I call, either I'm staticky or the person I'm talking to is staticky, and then either it'll wear off after a while and then it will just stop, or we'll hang up and call again and then it will usually work. I don't know why.
I think I should just ask the question, where you just read the question I sent to you earlier, and then just use the microphone. That's good, and then that's very, very clear from you.
Yeah, I'm having some trouble understanding you because of the static. Sorry.
Okay, so let's start then. Questions we have. So you could just read them, comment them, and make the answers.
So should we just go down the list and?
Yeah. That would be fine.
Yeah. So the first question I have here is monads in Go. Are there any implementations? So I had to look around for this one. I mean, I'm kind of familiar with what monads are and what you might use it for. I probably whoever's asking this knows that there's no built-in language support for monads like there is in Haskell, for example. I did find somebody who looks like effort. Well, it hasn't been updated in a little while, but somebody made a serious effort to implement monads in Go. So I've got a link to the GitHub repo I can share. So should I just paste it in the chat, or I don't know.
You could just put them into your mail or share via
chat. Just email it to you.
Yeah, just email it later.
I've got all the notes in my email anyway. Okay, I'll do that. So I will email Roman the link at the end. Okay, so question number 2. Is there any replacement for generics, and why are there no generics in Go? So, well, first of all, maybe some people would like a definition of what generics are. Probably anybody who's written code in a statically typed language probably knows, because most statically typed languages have some form of generics. In Java, they're actually called generics. In C++, you have templates. C doesn't actually have any, but you can kind of hack them in with macros. So basically, it's a way of declaring a generic data type over a variety of types. So you could make like a linked list type and say this linked list can contain any data type. So basically your alternatives today, because Go doesn't have this feature, your alternatives are you can write your type or your function using the empty interface, and that's what some places in the Go standard library will do. Like if you look at the package list, container/list, that's what they do. The interface of the list just uses, or the API uses the empty interface type. So the major downside with that is when you get an item back out of the list, you have to use a type assertion. It's like a downcast, because the Go runtime has lost track of what type is really held inside the list. So that's kind of annoying. It also means that if you have a list that you want to be only integers, then it's still possible to put in a string if you make a mistake. So it's not type safe. And then the other thing you can do is you can generate code with tools that are out there. This is probably a little less common, but you can do it. So then there's the question of why are there no generics? And basically, the designers say that they're open to adding generics to the language, but they just haven't settled onto a design yet, because generics are quite a complicated feature. And so they really want to make sure that they get the design right before they add them to the language, because it's, it complicates the language specification, it complicates the implementation, and they want to be sure they do it right. And so they're basically in no real rush. And I think a lot of the designers don't see a lot of urgency in adding generics, and there's it's kind of controversial, because a lot of users of the language see it as quite a bit more urgent than the designers do. For example, I'm someone who would like to see generics added to the language sooner rather than later, but we just have to wait. I don't even know if it ever will happen, but we'll see. I'll also include, there's an FAQ on the golang.org website addressing this. I'll include that link in my email to Roman afterwards. So question number 3 is, what about tail call optimization in Go? So tail call optimization, for anyone who doesn't know, is if you have a return statement and the return is a function call, the compiler can, under certain conditions at least, optimize the function call into just a go-to instead of actually paying the cost of the function call, and reuse the stack frame that it used for the current function. So a lot of functional languages actually require the compiler to do this because they don't have a way of writing loops. So the only way you can write a loop is by using recursion, and then you have to rely on tail call optimization so that you don't get a stack overflow and blow up your stack. So Go does not have required tail call optimization, and it probably never will, because the designers say that basically they don't want to lose the stack frame information, because if you have tail call optimization, it can kind of mess up your stack trace if you print out a stack trace, because you might see only one stack frame, but really there were a bunch of other ones that got skipped over because of tail call optimization. So they want to keep those nice stack traces. It's still possible for a compiler to implement it and be compliant with the spec. And I'm not positive, but it's possible that GCC Go might, under some circumstances, optimize tail calls, but I'm not sure about that. There was one more thing I was going to say, but now I forgot what. Well, I don't think it was that important. Yeah. Okay, so the next question is, how do you use lambda expressions in Go? So I'm assuming that a lambda expression would just mean an anonymous function. That you could kind of define them differently. And this is a question that's pretty easy to answer, but it's mostly easy to answer with a little code snippet. And so I think that's what I'm going to do. I'm just going to email Roman a code snippet that shows how to use anonymous functions, which are Go's version of lambda expressions. One is number 5. Is there any pattern matching in Go, and how does it work? There isn't really pattern matching. The closest thing would be a type switch, but it's really not the same as pattern matching. So a type switch is where if you have an interface value, you can write a switch. It looks kind of like a normal switch statement, but it switches over types. I'll email Roman another code snippet for this one. But basically, you have an interface value, you switch over all the possible types you might want to handle for that interface value, and you can have a default, and you can do different things in the different cases. But if for it to actually be pattern matching, you'd probably want it to be able to handle struct values and things like that. And there's nothing that can do that. Well, yeah, not really. You can use struct values and switches, but you can't do field wildcards and stuff. So, yeah, the answer is basically no, but there are a few things that are somewhat pattern matching like that you can do. So next question, number 6. Are there any type introspection / reflection / metaprogramming features, and how are they implemented? So probably the main thing here is the reflect package. Basically, you can supply a value to the reflect package, and it can tell you all kinds of things about what type that value has, and you can, if it's a struct or some kind of composite type, you can dig into the individual fields, or if it's a map, you can dig into the keys and the values and all that. And how does it work? Well, basically, when you pass a value into reflect, it becomes an interface value, and an interface value has 2 parts to it. It has the actual concrete value, but it also has some type information. So the reflect package is able to look into that type information and figure out all it needs to figure out about the value's type. Yeah, so if you have any more questions about that, it's probably best to just go to the reflect package documentation and read through that. And there's a really good blog entry about that on the Go blog, and you can probably find other blog posts or examples. There's lots of stuff out there. Number 7, why are there 2 different compilers? There's the main compiler, which is usually called GC, and there's GCC Go, which is based on GCC. So there are a few reasons. Basically, having 2 implementations kind of keeps us honest. It helps us write a clear specification. Like if there are any parts of the specification that aren't clear, those parts kind of get picked out a little bit more easily, because there are 2 different groups of people that are reading the specification and implementing a compiler based on it. It helps find bugs. as well, and they can also focus on different things. Like traditionally, GCC Go has done a better job of optimizing code, but it hasn't done quite as well at some of the concurrency and scheduling stuff. I'm not sure how true this is today, because GC is getting better at optimization, and I think GCC Go is getting better at concurrency. So I don't know. It's been a long time since I've used GCC Go, and I don't think it actually sees that much use in practice. Most people use GC, which is kind of sad, but it's just the way things are. Number 8, what are the differences between coroutines and Go routines? So coroutines are usually kind of separate code path. This is okay. Coroutines usually all run on the same thread. So you'll have the same thread usually switching between different contexts or different stacks, doing different things all concurrently, but there's no actual parallelism. Like usually with coroutines, you don't need to synchronize when you modify variables, because there's no chance that there's some other coroutine running right now changing the same variable and that kind of thing. With Go routines are actually coroutines on top of threads. So a Go program that is using Go routines will have some number of threads running, and then every thread is assigned a Go routine that's currently running. But those Go routines can be passed all through different threads. I feel like I'm not doing a good job of explaining this. Basically, you can have many threads, many Go routines, and they're all kind of running many threads, many coroutines, and that's kind of Go routine. Basically, the way it's often described is Go routines are coroutines multiplexed onto threads, but it sounds kind of complicated if you're not already familiar with how it works. People often call these green threads too. You'll hear them referred to that way. The Go routines are basically the same thing. They're basically threads, but they're lighter weight because they don't have to allocate a full operating system stack. And in Go, the stack of a Go routine can grow dynamically to fit how much space is needed. So if you have some Go routine that's running deeply recursive functions, that the stack of that Go routine can grow and grow and grow as needed. So you're not committing as much memory up front as if they were all threads. Okay, well, that was kind of a rambling explanation, but hopefully I got some clarity there. Number 9, how does Go solve the problem of funarg? And I actually had to look this up because I had never heard of the funarg problem before. And basically, there's actually a Wikipedia article about it, which is what I read to come to my understanding. But it's kind of the problem of if you have closures that are capturing functioning local variables, where do you allocate those variables? And you really want to allocate them on the stack, but it's hard and you can't always do it. So Go solves this problem in a way that might seem very unusual to you if you come from a C or C++ background. So in C or C++, all function local variables are allocated on the stack. So if you do something like take the address of a function local variable and return it, you're doing something very, very bad. And C or C++ programmers will be horrified. But in Go, you can actually do this, and it's totally fine. And the reason is, in Go, a function local variable is not necessarily allocated on the stack. So the compiler is pretty smart and will either allocate a function local variable on the stack or on the heap, depending on how it's used. And it has an optimization pass called escape analysis that helps it do this. And so it's not always perfect. There are times where something could be allocated on the stack technically, but the compiler doesn't catch it. But it's pretty decent. So to answer the question, sometimes function local variables that are captured by closures can be allocated on the stack, but most of the time they end up on the heap. And so then it's not really an issue. Yeah. So the next question is number 10. What is the difference between the mechanism of actors / lightweight threads / fibers / quasar / ACA / async and await / future promise in JavaScript / Scala and Go routines? So that's a lot of stuff. And I wasn't familiar with all of it, so I had to do a little bit of research to figure out some of these things. So I'm basically addressing 3 of them mostly. I looked up Quasar, which is a library offering it for closure, and possibly, yeah, it might have been general to the rest of the JVM. And it offers lightweight threads. And these sound very similar to Go routines. Like they're probably kind of the same thing from the sounds of it. And they have channels that are similar to Go's channels. So to me, just doing a tiny bit of research, it sounded very similar. Actors, I believe is what ACA and Scala uses, are also similar, but there are some differences. So in an actor system, every actor has a mailbox, and that mailbox can receive messages, and all the messages can pile up forever and ever. There's no size limit to the mailbox. But Go's concurrency is based on CSP, where channels traditionally have no buffer at all. So the only time a message can be passed between 2 different Go routines, at least by default, is if those 2 Go routines sync up and one's ready to send a message and the other one's ready to receive a message at the exact same time. So there's no buffer at all. But you can make a Go channel and specify that it has a buffer so that those Go routines don't have to be synced up when they send and receive. But it's still a fixed size buffer, so that buffer can fill up, and then if the buffer's full and a Go routine tries to send on the channel, that Go routine is going to be blocked. So pretty similar. There are just some differences in the details. And then finally, promises in JavaScript. A very limited version of Go. One way you can use a channel in Go is you create a channel, create a Go routine, and give that Go routine the channel you made, and then you wait for a value on that channel. And when that Go routine is finished, it will send one value on that channel, and then you know it's done. So that's kind of what promises seem like to me. That version of Go routines and channels. And again, this is just from a little bit of reading I've done on all these. So I might be completely misunderstanding or wrong. Don't get too mad at me if I am, please. I'm doing my best. And then the final question is there any polymorphism, object-oriented programming, multiple inheritance in Go And are there any alternatives? So that covers a few different things. Polymorphism, interfaces cover most polymorphism needs. You know, I'm not going to get into all the details of interfaces because there's a lot of material, but that's your main tool when it comes to polymorphism. There's no inheritance exactly, but there's anonymous struct fields. So if you create a field in a struct and you specify only the type and you don't give it a name, then that struct will basically inherit all the methods from that type. And you can have as many fields in a struct that do this as you want. Now, there are a few catches. The first catch is if any of those types define methods or fields with the same names, then you can't use any of them. Basically, Go doesn't resolve any conflicts with the names. If there are any conflicts, it just says, well, I'm not even going to try. You just have to do your own thing here. And this is, well, I might write a code example to illustrate the second thing because it's sort of confusing to describe. Basically, if you're talking about inheritance in Java or some other normal object-oriented programming language, if you have a base class and a derived class, and the derived class calls into the base class, if the base class calls some other method, then it can call back out into the derived class again. But in Go, if you're using anonymous field in a struct, you can call up into the base class, but you can never call back down into the derived class. So it's a little bit more limited. And then, of course, because Go has actual standalone functions, you can sometimes use those to reuse code instead of inheritance. Honestly, I've never found the lack of inheritance in Go to be a problem. There are other features I would like, but inheritance is something I've never wanted. Yeah, so that's all the questions. Like I said, I'll send Roman a few things in email, which will hopefully help clarify a few answers, but that's it.
Okay, thank you very much for this interview, for the answers. Thank you for your time. And,
was there anything that was unclear to you, Roman?
I think everything was pretty clear, except one thing that you did not mention. It was metaprogramming. Is there any metaprogramming in Golang?
Yeah, probably your only real options on metaprogramming. You can do some metaprogramming-like things with reflect. I guess, what do you mean when you say metaprogramming? I mean, I know in some dynamic languages you can do all kinds of crazy things like monkey and adding new methods after a type is defined, things like that. Is that kind of what you're talking about, or? Yes,
it's kindly evaluating the code, running code from the string and so on, and the few things you already noted before.
Yeah, a lot of those kinds of things just aren't really possible. Like there's not really any way to monkey patch unless you get into like crazy unsafe code, which you should never write. Yeah, that's just kind of one of those things that comes with having a more static programming language, I think. You can't do some of that stuff, and that's okay with me for the most part.
Okay.
Okay.
So I think that's the answer. Thank you very much for your time, and see you later. Thanks.
Okay. Bye.